Hello. Marvin, if you don't mind, I'll start in Turkish a little bit. A short introduction and then switch back to English. Herkes hoş geldi. Bu akşamki etkinliğimizi İngilizce yapacağız. Marvin aramızda. Ben küçük bir Türkçe merhaba demek istedim herkese. Şimdi İngilizce tarafa dönüp Marvin'le şey yapacağız ve kendisine bırakacağım sözü. Welcome Marvin. So Marvin is my friend, also a colleague, and we CNCG Istanbul group, we invited him for tonight to talk about the project called KCP. It's a CNCF project, and he's one of the maintainers of it. This is the first of the series, so we are planning to have bi-weekly online events from now on, and this is the very first one, and we start with him. So yeah, I'll just give the stage to Marvin, and he can just introduce himself and the KCP project to us, and then if you have any questions, just write them down, and he will be hopefully at least try to answer them whenever he can. So yeah, stage is yours, Marvin.
All right. Thank you very much for the introduction. Hello, everyone. Thank you for having me. It's a pleasure to be here and to kick off this series. So no pressure at all there, I guess. All right. Yes. So I today would like to talk about this project called KCP. Corey gave an introduction of it already, and I think we should just start right in. So let me start off maybe by introducing myself. So yeah, my name is Marvin. I am currently a team lead at Kubernetes in the engineering team over there. I'm also a KCP maintainer, as Corey said. So I'm working on this, as a CNCF maintainer. You can find me on some socials if you want to connect and reach out. I love to talk to people that bring their own story, how maybe KCP can help them. So hope to hear from you folks. All right. Let's start with an agenda because I want to give you a quick overview of what we will talk about today. So first of all, I want to do, well, it's not a history lesson, but I want to talk about Kubernetes as an API layer. I think most of you have, worked with that. And then we're going to do basically a little bit of, looking at the ecosystem and see what people build on the Kubernetes API layer foundations and how they've built an ecosystem around the Kubernetes API. Then I want to introduce KCP because first the background is quite important. Basically tell you a little bit about the core concepts there, and not finally, but then I'll dig deep into a certain aspect of KCP, which I like to call the API marketplace. Basically the ability to share and consume APIs. And then we're going to jump into a quick demo because I have plenty of time today. And well, I want to show you what KCP means in practice, and we're going to do a little bit of exploring around the KCP installation, and I'm going to show you some examples that we have. All right. Let's start. Let's start with things that all of you, I think, already know, but they set the stage. So that's why I briefly want to talk about them. So one of the things about Kubernetes is the API. It's a very central part. Well, it's the central part of a Kubernetes cluster. And when you interact with the Kubernetes API, you speak a certain type of REST. So if you look at this little graphic here, so resources in Kubernetes are basically the different endpoints that you can talk to. And all of it is basically HTTP or similar protocols. But the idea is basically, okay, Kubernetes, the API, offers many different APIs. And these APIs are first and foremost grouped. So this is what we see like at the beginning. So every API in Kubernetes is in a group. Then each API group is also versioned. So there can be different versions of a group. Then optionally, some resources in Kubernetes are namespaced. Not all of them are. And if they're not, they are like called cluster scope, but plenty of them are. And then there's a specific resource type. And the resource type basically defines a schema, because the Kubernetes API works on, well, kind of typed resources. So there's an open API schema that you can use to construct the responses and the requests that you want to send to a specific resource. And then if you want to interact like with a specific resource, well, you give it a name. Well, you give the name, not you give it a name. But this is what probably all of us do on a daily basis. We interact with these conventions, and we do it through different tools. We do it through kubectl. We do it maybe through some GitHub solution. But fundamentally, when you have a Kubernetes YAML file, it gets delivered to the Kubernetes API through this schema. And honestly, well, I find it pretty awesome. And the Kubernetes API, it's not really a byproduct of Kubernetes, because Kubernetes primarily was or is a container workload orchestrator, but the API has always been there, and it always has been front and center. But what has been, again, not a byproduct, but what has been a result of development in the space is the extensibility of the Kubernetes API. Because what you see here on screen, you can plug in your own resources. You've all seen that with custom resource definitions. And you can basically store kind of arbitrary resources in the Kubernetes API. And plenty of projects are doing that. So there are a lot of projects in the ecosystem that have extended the Kubernetes API to provide functionality. And some of them, like for example, kubedb or Rook, I would say they provide higher level abstractions. So they provide a way for you to manage storage that is running on Kubernetes, or Rook, for example, manages Ceph installations, among other things. kubedb gives you databases, but some of these, and I think I'll need to grab a glass of water, but some of these have a characteristic that is very interesting, because they extend the Kubernetes API layer itself. So if you have Kyverno here, Kyverno doesn't produce any workloads. What it does, it's a policy layer. So it extends the Kubernetes API's capabilities by delivering something that is kind of a meta extension, because the only thing that Kyverno gives you is changing the way that you interact with the Kubernetes API. And even more interesting is the case of Crossplane, because Crossplane basically doesn't manage Kubernetes workloads at all. It took the Kubernetes API to allow you to have a cloud-native way of provisioning infrastructure resources. But these, for the most part, live outside of the Kubernetes cluster that Crossplane is installed on. So Crossplane is basically just there for the Kubernetes API parts. It doesn't really care that much about the container workload orchestration parts. And I think that is where I want to go here. So, said it earlier, I want to say it again, the Kubernetes API is pretty awesome. It's extensible. It has a lot of engineering power that went into it in the last 10 years. Well, I don't know. Do I need to say more than the slide? The Kubernetes API is pretty awesome. I asked this question at one conference, and basically I asked if people agreed with this, and there were fewer hands than I thought. So I'm basically trying to show you why the Kubernetes API is awesome. Now, the thing with the Kubernetes API and its principles is that, well, it's still bound to the container workload orchestration part. So, for example, when it comes to providing custom APIs, CRDs, they are cluster scoped. But that means they, well, are available to everyone in the cluster, but that also means you can easily create conflicts, because once someone installed a specific API, no one else can install it themselves. And maybe they want a different version of it, or maybe they have modified it in different ways. And to be honest, Kubernetes clusters, and you see this often when you try to stretch Kubernetes clusters, they are not really meant to be global. I think the recommendation in general is create multiple Kubernetes clusters. And one more thing, and this is what I said earlier with Crossplane, you might not really need the workload orchestration parts of Kubernetes. If you want to run containers, of course, Kubernetes is your go-to, but what if you just wanted to provide APIs, and you wanted to provide APIs apart from workload orchestration? And this is, again, the example of Crossplane. Then you really don't need nodes and pods and, well, config maps maybe you need, but deployment, stateful sets, all of that, persistent volumes, you might not need all of that part, but you always get it with Kubernetes. So this is not the first, okay, I'm not the first person who had these thoughts. There are plenty of solutions in the ecosystem that are already taking the Kubernetes API and trying to separate it from the container orchestration parts. So there is, first and foremost, something that has been around for like almost as long as Kubernetes is around, and that is hosted control planes, where you basically treat the Kubernetes control plane, so the API server, the etcd, the scheduler, the controller manager, you treat them as workloads themselves, and you run them on Kubernetes. That is basically something that a lot of solutions already do, to run Kubernetes clusters at scale. And this results in you getting Kubernetes clusters for like relatively cheap. If you deploy a control plane with three VMs, you might have a lot of overhead, but if you put them as workloads onto another Kubernetes cluster, you can start to reap all the benefits of Kubernetes, of being able to effectively schedule them and share resources. But still, this still means that you have control planes that are probably taking a few gigabytes of memory, because there's a lot going on. This is ideal, I think, if you want to like run Kubernetes clusters at scale. But if you just want to run the Kubernetes API, you have a lot of things here that you don't really want. So what if we virtualized API servers instead? Because we don't need them. We don't need the full control plane. We just want API servers, and we want them to be, well, cheap. And this is something that in KCP we've called logical clusters. So logical clusters are basically the idea of, okay, I want Kubernetes API endpoints, but I don't want to pay the costs of spinning up a new API server process with everything that is behind that each time that I want to create a new logical cluster. And logical clusters could be basically used for teams isolating themselves. They could create their own APIs on their own CRDs. They could self-manage. So how do I get to that? And the idea basically that KCP is building on, and that I would like to propose you for your consideration here, is it's okay to share a data store, but the software, like there can be an API server above that is kind of like aware of logical clusters. It's basically a system of multi-tenancy. And that means that each logical cluster from the outside is basically its own kube API server-like endpoint. So if you point a client to a logical cluster, it will, and the client could be kubectl, it could be also something else. Then the client will, do API discoveries. It will fetch some resources, and all of that will be fine. But there's no dedicated API server process. Each logical cluster, like each logical cluster that you talk to, it basically it's going through one API server that basically sorts, okay, which logical cluster is this request coming from? Okay, then I need to apply different airbag. I need to make different APIs available, and then it goes to the data store and fetches data, the data from there. So this is basically logical clusters. And this is basically what KCP has built. And this makes it cheaper to spin up, new, logical clusters than the previous attempts at solving this problem. So what is KCP? KCP is a horizontally scalable control plane for Kubernetes-style APIs. And the important bit here is the API part, because as I previously said, we don't care about the container workload orchestration. So basically, from here on now, we are just talking about APIs. We are not talking about containers anymore. So KCP is a Cloud Native Computing Foundation Sandbox project. It has been accepted into the Sandbox in 2023. The project has been going on since, I think, at least 2021. So it has been going on for a while now. And KCP basically tries to solve these questions, solve these problems, and tries to provide an implementation of this logical cluster idea. So in KCP, this logical cluster concept has been implemented with something that we call a workspace. So a workspace is, a unit of isolation for multi-tenancy. It's basically a virtual Kubernetes API server. Because it's its own API server on a logical level, it has its own API resource types. So every workspace in KCP, you have different APIs available. This is no longer where you install a CRD and it's available to everyone using a Kubernetes cluster, because if you install a CRD, it's only limited to a workspace. And the workspace, next door doesn't have that CRD, so it doesn't have the API. I think that should speak for itself, but because it's a unit of isolation, objects in a that you create or manage in a workspace, they don't exist in other workspaces. Teams can create their resources, their secrets there, and other teams cannot access them. Because KCP has this multi-tenancy feature and workspaces are a unit of isolation, workspace owners can now basically have full cluster admin permissions within the workspace, because permissions do not exceed the workspace. So this is a new kind of security boundary, which allows workspace owners to be much more autonomous in their work. And because of the concept of logical clusters that we talked about earlier, workspaces are cheap. They do not cost a lot, because creating a workspace is basically just telling the shared API server to, allocate a new chunk of storage to this workspace. And that is basically it. Then requests go to that part of the storage, but a workspace is there in a couple of seconds. It's cheap, and unless you use it, it basically doesn't take any storage at all. Okay, one important characteristic about workspaces is that you can stack them into each other. You can create a file system-like tree structure. So you always start out with a root workspace. That is, the root of your workspace tree. And then you create workspaces within that workspace. So workspaces are just another Kubernetes API resource. And when you create them, new workspaces, new logical clusters are being created on the backend. And there are a couple, like I basically am showing a few examples here of URLs. So I said earlier that each workspace is its own kind of like Kube API server endpoints. And all of the URLs that you see on here, they behave to a client, to a, let's say, unsuspecting client, they behave like different API servers, like different API server endpoints. So if I point my kubectl at the top level URL, I'm going to get very different responses than from the other URLs. And as you can see here, there are technical limitations, but you can stack as many workspaces into each other as you want. Because this is a tree-like structure, so it's very reminiscent of a file system, we have provided a kubectl plugin to navigate them. So if I start from the root workspace, which you see at the top here, and I check out, okay, what workspaces, so kind of, you know, if you navigate a Linux file system, what kind of folders are there in my root folder /workspace? Okay, there are a couple here. Then I switch to that. I kind of, change directory. And then I check, okay, what folders are in this folder now? And so on. So this plugin basically implements like CD-like semantics. So this is how you can browse your KCP installation, your workspaces easily. With these basics in mind, let's jump to what I earlier called the API marketplace. So like I said earlier, container workloads, we don't care about these. So what do we care about? The idea in KCP, I think, is building an API layer, and that API layer could be used for something like a SaaS platform. It could be used for something like an internal developer portal. Sorry. The idea is that you can offer arbitrary services through it. And KCP just basically focuses on the problem. I have a service that I'm offering. Let's say I'm a database administrator, and I want to make this database service easily self-serviceable to anyone in my organization, or maybe I'm selling access to it, then it would be more like a SaaS. And that is basically the part that KCP is interested in. And that is why I'm calling it the API marketplace. There's someone who, wants to, let's say, sell a service, and there are also consumers. And KCP can help them basically connect automatically. And how, we're going to walk through a little bit. So I had the example of the Postgres or like a database team earlier, or a couple of seconds ago, actually. And honestly, I think someone who runs databases is probably not very interested in providing an API layer to allow users, consumers to request databases, because that's kind of a waste of their time. They want to run databases and they want to be good at running databases. And that is why I think that service teams, they shouldn't be bothered with, writing their own API implementation. They should have a platform into which they can plug their services and then focus on delivering those services. And that is why KCP is so powerful. Let's start. Let's walk through the process, and I'm going to show you a couple of resources that you can create in KCP within a workspace to create, to define, and to consume APIs. So we're going to start on the service provider side. So in our example, on the database team side. So there's something in KCP that's called an API export. And API exports, they look like this. So they are Kubernetes style resources. So you can apply them with kubectl. You give it a name. That is my API's name. And then I reference something that is called a resource schema. And a resource schema is basically a CRD, at least when it comes to, well, the structure of it. So if you have a CRD, you can basically convert it with an easy command or with an easy go library to become a resource schema. And that is the KCP equivalent. Why do we have resource schemas and not CRDs? So CRDs actually do two things. The one thing that they do is define, well, the schema of your custom resource. That is all what we're all aware of that. But they do a second thing. When you create them, they also register that API, and the API becomes available. So that's the two things that CRDs do. They define the schema, but they also register the API. And it's basically a 2-in-1 deal. And KCP decouples that, because KCP has the API resource schemas, and they only define the schema. If you create an API resource schema in KCP, the API is not available anywhere. So for that, you need to put them in API export and reference them there. And an API an API export is basically a collection of schemas that you have put together as a bundle. Now, as a developer, now we have one more concept that I need to introduce, and that is a virtual workspace. So a virtual workspace is a component in KCP, or something that you can also develop yourself, that provides a computed view on the world. And with that, I mean KCP. So if I create an API export, I want to make, well, this API that I've created available. Now the problem is that my API will be consumed in different workspaces. We're going to see that in a bit. So how do I implement a controller that is able to reconcile, let's say, all my database objects across a whole KCP installation? You do it by developing a controller that connects to a virtual workspace. The virtual workspace basically gives the controller access to my database resource, but just my database resource across all workspaces. So this is kind of it's a computed view. It's a slice of what is available in the KCP installation, but it's the view that the controller should have. And this is basically how you implement your service. You talk to a virtual workspace, you have your controller that talks to the virtual workspace and reconciles objects. So this is kind of, well, very similar to what you do in Kubernetes already. As an example, the API export virtual workspace, well, kind of looks like this. So when I wrote these slides, I chose pizzas as a resource that I'm offering, and certificates, which is an odd combo. But to reconcile these, I'm connecting to a specific endpoint, and that specific endpoint only gives me pizzas and certificates. And then I can have a controller loop, a reconcile loop, that takes these and, well, does whatever you need to do to provide your service. Generate TLS certificates, or, I don't know, start the oven to put in the pizza, whatever your controller does, really. But this is basically how you implement it. And we can briefly look at this slide, but I'm also going to show you a brief example. So there's a controller runtime fork that we maintain. This controller runtime fork is KCP aware. And apart from a couple of changes in your code, if you have a controller, a Kubernetes controller, you can probably modify it to be KCP aware in a day or two. So that is how easy you want to basically make changing the scope from a single Kubernetes cluster to a KCP installation, which can have, well, several hundreds of thousands of workspaces. Okay, that is the the producer side, the service provider side. Now let's talk about the consumer side. So the consumer side creates something that is called an API binding. And that basically does the following thing. So if you run kubectl API resources, it goes to the API discovery endpoint of your Kubernetes cluster, or in this case, your workspace, and shows all the different API resources that are available. So all the basically schemas that the Kubernetes API, or in this case, the KCP workspace, is aware of. And if I look at this list, something that shows up here is the workspace resource. And the workspace resource, well, basically is exactly that. It allows me to create child workspaces within this workspace. And KCP kind of, let's say, dog foods its own solutions. And this API is available in the workspace because there's something called an API binding. And the API binding is, again, a Kubernetes resource. You can see it here as an example. And the API binding references an API export. So the resource that we saw earlier. So a KCP installation comes with a couple of API exports by default. And the tenancy API, which includes workspaces, is the same thing. So basically, every workspace gets instantiated with an API binding to some of the core APIs that everyone should have available. But KCP builds upon these same technologies to, well, provide its own services, which is, well, workspace and API management. So, and this is basically where, well, I talked earlier about KCP workspaces isolating teams or parts of an organization or customers from each other. Now, of course, well, in most organizations, hopefully, teams end up working together. And in an organization, if you have a database team, you want to profit from their experience. That is, the whole idea of, okay, the database team would want to provide a service. And because of that, well, there are some ways to basically cross these boundaries between workspaces, and API bindings are one of them. So a team that sits in one workspace or that owns one workspace can create API bindings that connect to API exports owned by different workspaces. And this is basically where you can, well, model your organizational structure and then have a collaboration between these teams. And a team can be, or like a workspace can consume APIs from many different other workspaces. So if you're a consumer, you can create API bindings referencing basically API exports all over the KCP root, the KCP workspace tree. Of course, this, well, needs to be secured. So KCP comes with some light extensions of the Kubernetes RBAC mechanism. And one of them is basically that to reference an API to reference an API export from an API binding, you need a specific verb on the resource. And this is basically on the service provider side. So in the workspace of the service provider. So even though I'm a cluster admin in my own workspace, in my consumer workspace, I won't be able to set these permissions because they exist in a different workspace. So this is basically how teams can secure access to the APIs. Now, there's a lot of, well, not exactly theory here, but now I want to show you KCP a little bit more hands-on. So I think we should just jump right in. I've prepared a little walkthrough, and I think this is basically where we will try to go from. All right. Then let's take a look. So KCP, Corey.
Yeah, let the fun begin. No, I'll not say anything.
Okay. All right, so let's get our hands dirty a little bit with KCP. So because KCP is based on the Kubernetes API server, it's quite a complex beast, but we have a developer mode for it. So running KCP on your own local system, as long as you have Go available, is pretty easy. I've compiled the KCP binary, and if I do that, or after I do that, I can just start a KCP server. It comes with its own embedded etcd and with some other embedded components. So this is not a production setup, but it's making it easy for us to get started. So I'm going to do this. And now KCP will start up. It's very chatty. Don't be scared by that. It's setting itself up. It's bootstrapping some resources that it needs. For example, the API exports that I talked about earlier. KCP creates them on the first time of starting. We're going to run through this a little bit, and now I can talk to it. So I can do basically this. This is what I showed earlier on the slides, but I can talk to it. It's running on a local port. And this is the list of APIs that I have available in the root workspace. So this is basically the starting point. This is what every KCP installation has. And you will see that some core APIs have been preserved. So we basically took from the Kubernetes APIs whatever we found useful in a more like API-centric environment. So for example, config maps still exist, secrets still exist, service accounts also still exist. But these kind of things, and namespaces also, they are kind of universal. They also make sense in what we're building with KCP here. And as a little shout out, you can see the workspaces here. This is basically what I talked about earlier. The API is available from here. So if in my root workspace, I basically check the workspaces, I get a response. It's just that this is empty at the moment because, there are no workspaces at the moment. All right. Now let's populate this setup a little bit. So we have, as I said, a controller runtime fork, and the controller runtime fork has a KCP specific example. So what we're going to do is we're going to let the example resource we'll bootstrap the example resources, so we have something running on our KCP installation. So we're going to take a quick look here. We want to do the KCP bootstrap. And this is basically setting up a service provider and a consumer kind of situation. So we've created a couple of resources, and now I can show you a little bit of navigation on this KCP setup, because now we have workspaces. And we have 3 workspaces already. So we have and I'm going to start from the bottom here, the widgets workspace. And in this case, this is someone providing a service. So we're going to go in there. And this is also basically, this is a little kubectl plugin that I wrote for myself because I like these interactive command line tools to navigate the file system. And I thought, we can do the same with KCP workspaces because it's a tree. It's basically the same as a file system. So I'm going to go into the widgets workspace. So now I'm in a different workspace. And that also means that now we're first going to check, what's the list of workspaces in this workspace. They are now here because there are no child workspaces nested into this one. But what is here is a API export. So this is basically what we talked about earlier. This is where a service provider defined their API and basically made it available. So this is the API export. On this side, basically, I want to provide a service. If we now switch to consumers, now there are 2 consumer workspaces. So we can choose one of them. We're going to enter the consumer 1 workspace. And now, if I check here, there's an API binding here. And that API binding, if you look at it, it has, well, a lot of status, but if you look at the specification, it has the API export reference that I talked about earlier. So this is basically the point at which, okay, there is an API export with a name, and it exists in a different part because I referenced a different workspace here. And because this API binding exists and the status is looking all fine, everything is, well, splendid, I can take a look at the APIs available in this workspace, and I will see, where is it? Here is it. I will see my new API type, the widgets. And basically, this is the service that the other team provides to this consumer. Now, we're going to go back to the root workspace. Oh, I should also go up a level if I want to do that. Now, I talked about, well, you need a controller. This is the same as in Kubernetes. When you install a CRD, you need to install a controller with it, which reconciles your resources. So what we're going to do is we're going to start the controller. And this controller is KCP aware. So it connected to the workspace, to the widgets workspace, to the service provider workspace, looked at the API export, got the matching virtual workspace endpoints, and is now talking to that virtual workspace. So it only sees widgets. So basically, and well, 2 resources more. It also sees config maps and secrets, but the point still stands. It has a very much reduced view of what is going on in KCP. Now, let's do something. Let's create a widget. For that, we need to switch again because the root workspace actually doesn't have this API available. We never created an API binding for the root workspace, so I can't create widgets there. So we're going to go into the consumer one, and we're going to create a widget. So now I have my first widget, and the controller that is implemented here, it's a dummy controller, doesn't do a lot. In fact, it does very little. But what it does is, and we're going to see this, we're going to take a look at the widget. And the widget has status. And the status is the count of widgets in a specific workspace. So the controller is KCP aware. It processes all widgets, but it also knows which widgets are in which workspace. So we're going to basically see this. If I create another widget, because I don't know, I like widgets, I'm going to get a second widget. And if I look at the resource now, well, the old one doesn't get updated, but we don't care about that. But the new one here, the new widget, has a total of 2 here, because when it got reconciled, well, the list of widgets in this workspace was 2. Very simple. The controller, again, doesn't do much. Now, we're going to do a quick little context switch. We're going to go up 1 level. We're going to go to the consumer 2 workspace. And now we're also going to create a widget here. So when we do that, and maybe we're, going to create a couple more. If you look at this, this is the one most up to date. We see that there's a total of 3. And that's correct, because that's the amount of widgets in this workspace. But the controller is reconciling, well, both this widget and the widget that is living in a different workspace, so on a different logical cluster. And if we basically, well, if we, just to check, if we go to the consumer 1 workspace again and we create another widget, then the overall amount of widgets on the KCP installation would be 6, but within this workspace it would be only 3. So just to make sure, we're going to see, 3. Okay. So both workspaces have 3 widgets. The controller reconciled them both. This is just one, controller running, doing both things. And that is basically what this example controller does. It doesn't do a lot, but it implements this multi-tenancy of the controller while not divulging any other resources from different API providers, because this is running through the virtual workspace, which doesn't give you access to, I don't know if the database team is there also in addition to the widget team. I don't see any databases from here. So yeah. Now, I think I'm pretty much on time with, where I wanted to land with this demo. The codes, and we can basically switch to the slides again. The code for all of this is obviously open source. The controller runtime example is here. KCP, the main repository is here. There is this kubectl plugin that we've been using. First of all, the non-interactive one, the main KCP plugin, and then the dynamic switcher is something that I'm currently hosting. And yeah, I think with that, I am at the end of my demo. So first of all, thank you very much. I think it's a lot of information.
Yeah. Well, thank you very much, Marvin, first of all. I think if we put it in and as an analogy, the relation between Kubernetes API and the workspaces are similar to Linux kernel and the containers. Kinda.
I mean, I think it's more like if you basically got new Linux kernels for free. So it's like virtual machines if the law of physics didn't exist.
True. Yeah. Yeah. And yeah, it's also good that I think this is an important project for platform engineering teams where different teams within the organization can provide their services, and with the API bindings, other people can just use those services. So I think that's one of the important stuff. So yeah, in terms of PaaS or SaaS or whichever you call it within the company, then KCP would serve there quite well. I don't see any questions from people. If there are any, please just comment there.
Is everyone still there? Yes. Did I put everyone to sleep?
I don't know. Yeah, I mean the recording will be on our YouTube channel, so they can also watch it later when when they wake up again. Will the slide deck be available, Marvin?
Yes, of course. I mean, I'm not sure how.
Yeah, the YouTube video will be available. I think we can also share the slide deck on our CNCF community page. I believe we can also do that. Other than that, I mean, we normally set like something for an hour, so I think we are also on time. Do you have any other like announcements or comments or calling people in to help out with the project, help out with maintaining it?
Yeah, I mean, I actually have some wrapping up slides. They are kind of redundant, but so basically, maybe to make my case again, because this was rather technical, but APIs are eating the world. Everyone is offering APIs. Maybe you're offering AI through it because that is eating the world right now. But APIs are everywhere, and honestly, providing APIs, like writing your own API layer, is kind of cumbersome with very little gain from it. And the Kubernetes API layer has been, a huge success. It's an industrial standard, like an industry standard. And why not build on top of that? So let's start bottoms up. let's use the technology that a lot of us have been working with for quite some time. Kubernetes is 10 years old at this point. And let's build a platform that is, well, kind of, open to everyone. There's no overhead involved in providing your services. You can bring them, well, to everyone in the organization with a rather easy concept to apply. And the hope is also that through these, through the concepts that KCP takes from Kubernetes and extends them, maybe we can create standards for these kind of internal developer platforms, SaaS platforms, whatever you're building. So basically everything on here I've already told you, but it's a community project. It's under the CNCF umbrella. If this resonated with you in any way, we're on the KCP dev channel in the Kubernetes Slack. We always welcome new people. We have a bi-weekly community meeting, and yeah, it would be great to hear from you. And I think now that is my last slide.
Okay. Yeah, that's great. Wonderful. Yeah, thank you again very much, Marvin, for first accepting our invitation and being with us very late this evening, and for the opening event for our next series. So we planned for in 2 weeks, I think August 28th, we will have another online event. I don't know if we got the last confirmation, but it will be about a case study from a well-known Turkish company, like an international Turkish company. A case study about their Kubernetes and cloud native usage. So yeah, but the announcements will be out soon, hopefully. Yeah, I think that's it, and I don't see any other questions. So thank you very much, Marvin. I think we can call it today.
All right. Thank you very much for the invitation. Yeah. It was a pleasure to be here.
Yeah. And, yeah. Likewise. Okay.
Thank you.
And
bye-bye.
Yeah. Bye-bye.